Okay, so today's review is going to cover measurement. So we're going to be looking at different conversions and then calculating different types of measurement like surface area and volume. So first we want to look at the metric system. So with our metric system, we are going between our different units looking at the prefix for the base unit. So as we work to our bigger units from the base, we want to divide going to the left, and when we go to our smaller units, we want to multiply. Okay, so this is all by 10. So looking at the first one here, we are going from 125 grams to milligrams. So grams is the base unit, and we're moving over to milligrams, so we're moving over 1, 2, 3. So that means we are moving the decimal place over 3 to the right. Or it's going to be times 10 times 10 times 10. So if we bring the decimals here, we were to bring it over 1, 2, 3 more, we're adding 3 zeros. So that gives us 125,000 milligrams. Next one, we're going from 10 liters to milliliters. So same thing here, we're going from a base to milliliters. So again, we are multiplying by 10, multiply by 10, multiply by 10. So moving it over 3 decimals. So we end up with 10,000 milliliters. The next conversion is going from centimeters to meters. So starting with centimeters and going to the base unit of meters, we are going to the left 1, 2. So we are moving the decimal 2 to the left, or dividing by 10 and dividing by another 10. So moving it over 1, 2, we get 0.0142 meters. And the last one, we're going from 10.5 kilometers to meters. Kilometers is a bigger unit. Going to the base unit, we're going to the right, 1, 2, 3. Okay, so that means we're moving the decimal 3 to the right, or multiplying by 10, multiplying by another 10, multiplying by another 10. So 1, 2, 3. We have 10,500 meters. Okay. Then looking at the imperial system, so this doesn't work as nicely. We need to use a chart in order to make our conversions here. We can't just multiply and divide by 10. So looking at this here, whenever we make our conversions, if we're going from the left to right side, we're going to multiply by the number. And if we're going from the right to the left, we're going to divide. Okay, so you're going to be getting these charts for your exam. So the first one is going from 12 feet to inches. We notice that's this first one here. Feet to inches. Since we're going left to right, we want to multiply by 12. And that'll give us 144 inches. Okay, next one, 10 ounces to pounds. And we have our pounds and ounces right here. We're going ounces to pounds, so we want to divide. 10 divided by 16 gives us 0.625 pounds. And the last example, going from miles to yards. Miles to yards is right here. Since we're going left to right, we're going to multiply, so it will be 2.5 times 1,760 gives us 4,400 yards. Okay. The last type of conversion is when we're working between both imperial and metric. So again here with these, if we're moving left to right, we're going to multiply by the conversion, and moving right to left, we're going to divide. So the first one here, we want to go inches to centimeters. Inches to centimeters is that first conversion there. Going from inches to centimeters, left to right, we multiply. So 10 times 2.54, we get 25.4 centimeters. Next one, we are going from 12 fluid ounces to milliliters. So looking for that conversion under capacity, fluid ounces to milliliters. Again, we're going from left to right, so we're multiplying. So 12 times 29.6 is giving us 355.2 milliliters. And the last conversion we have here, 12 miles to kilometers. Looking for that conversion. Miles to kilometers is right here. Again, left to right, multiplying, so 12 times 1.609. And that gives us 19.308 kilometers. So now moving into our geometry, looking at area, perimeter, surface area, volume. So with all this, you're going to be given a formula sheet. So as well as that conversion chart, you will be given a formula sheet with all the formulas for all these types of measurements that you might need to find. Okay. So first, we are asked to find the area. So we notice we have a composite shape here. We have one piece, that's the triangle, and then we have a semicircle at the bottom. So the area of a circle is pi r squared. Since we have a semicircle, we're going to divide that by 2. So pi r squared divided by 2, and we need to add that to the area of the triangle. The area of a triangle is base times height divided by 2. Okay, so the measurements we have here, pi is 3.14. Radius is halfway across a circle. So if we have the diameter of 8, halfway across will be 4. So 3.14 times 4 squared divided by 2. And the measurements for the triangle, we have a base of 8. The height of the triangle is 3, and that gets divided by 2. Okay, so we'll have 4 squared times 3.14 and divided by 2 gives us 25.12, and we're adding 8 times 3 divided by 2, which is 12. Okay, so adding those together, get 37.12. We're working with centimeters, and area is always the units squared. Now, when we look at perimeter, talking about the perimeter of a circle, that's called the circumference. Finding circumference is pi times the diameter, but we only have half the circle. So pi times diameter divided by 2 will give us the circumference of our semicircle. So 3.14 times 8 divided by 2, and that's going to give us 12.56 centimeters. And now we need to add on these two sides of the triangle. So what we notice we have here, we have the height and the base of the triangle, but we don't have these sides. Okay, but what we do notice is that this is broken into two triangles, and those create a right angle triangle with a height of 3 and a base of 4 each. So that means we can find the hypotenuse of the triangle, which is the length that we need to find perimeter. So finding that hypotenuse, we're going to use Pythagorean theorem. So c squared equals a squared plus b squared. C squared is equal to, our sides are 3 and 4, so 3 squared plus 4 squared. So we will have 3 squared is 9, 4 squared is 16. When you add that together, it's 25. And then you're going to bring the squared over, it'll be a square root. So c is 5. So both of these lengths here are 5. Okay, so finding our total perimeter, we're doing 5 plus the circumference of the semicircle. So perimeter is 5 plus the 12.56 that we found, and that gives us 22.56 centimeters. Okay, perimeter, our units are centimeters. Next question. A landscaper is preparing a rectangular flower bed for planting that measures 5 meters by 3.5 meters and will have topsoil to a depth of 12 meters. Clearly my drawing is not to scale, so don't go by that, but we do have the 3 measurements there. She can buy bags of soil that cover 50 meters squared each. How many bags must be ordered for the bed? So if we want to fill this, we want to find volume. So that is volume of a rectangular prism is length times width times height. So 5 times 3.5 times 12. And that gives us 210 meters cubed. And it's telling us that each bag covers 50 meters squared. So we want to take our measurement of 210 and we'll divide by the 50. and that'll give us 4.2. And that means that she will need to buy 5 bags in order to cover that amount of area. Okay, and last question here that we want to look at. Dean is building an above-ground pool with a rectangular deck in his backyard. His backyard is 35 by 110, and the pool has a diameter of 15. The deck will measure 30 by 6.5. Calculate the amount of sod that will be needed. So here we're wanting to calculate surface area. So there won't be sod needed for the deck or pool area. It'll only be the shaded area. So what we're going to do is find the area of each piece. We'll find the area of the whole yard and subtract the area of the deck and the pool to find the amount of sod. So the area of the yard is a rectangle, so we're using length times width, and that's 35 times 110. So that's 3,850. Finding the area of the deck, it's also a rectangle, so length times width. Our dimensions here are 30 times 6.5, and that gives us 195. And our last one is the area of the pool. This is a circle, so we're using the equation pi r squared. So if the diameter is 15, we need to divide that by 2 to get our radius, which is 7.5. So we'll have 3.14 times 7.5 squared, and that'll give us an area of 176.625. Okay, so the total amount of sod is going to be the area of the yard, subtract the area of the deck, and subtract the area of the pool. So 3,850, subtract 195, subtract 176.625. And we get a total of 3,478.375 feet, and area is squared. Okay, so again, there will be a formula sheet available to you. I will post that so you can see what resources you'll have available to you for the exam. And if you have any questions, please let me know.